right, so let's take a look at, so again, you have the 7.1 notes app, that sheet that I showed you. Open it, use your Cami to annotate it. Okay, so looking at the first one, sodium. The symbol is capital N with a lowercase a. Okay, so what we're going to be doing is we're going to be writing the abbreviated form of the electron configuration. We don't need the entire configuration, we just basically need the end part. We need to figure out what the valence electrons are, so that's going to be at the end. So if we're looking up sodium, pull out your periodic table and look up sodium. What is the atomic number for sodium? You can go ahead and say it or just put it in the chat. What is the atomic number for sodium? Anybody? Sodium. Good. Okay, so there are 11. The atomic number is 11. I'm just going to put that up here. So the atomic number is 11, which means that it has 11 electrons because we're talking about the neutral atom. So atomic number is your number of protons. And if it has 11 protons, then that means it has 11 electrons. Okay, so what we're going to do is write the electron configuration for this. And we are going to use the abbreviated form. So the abbreviated electron configuration is your noble gas configuration. So what noble gas would I write down for this? What noble gas would I be using here? Sodium's atomic number 11, so yes, the noble gas that is right before sodium is going to be neon. So you're going to write neon. So remember, once you write that down, that means you do not need to write the electron configuration for neon. So putting the symbol for neon in brackets is like writing the entire electron configuration for neon. So what is the next thing that I need to write then? Since neon is atomic number 10, that brings us to the next level, which sodium is on, and what is that? So sodium ends with a what? You're going to have neon what? What does it end on? What level is sodium on? What energy level? Good, it's level 3. And yes, it ends with an S1. So as far as your first group, those all ended in S1, and sodium is an S1, so 3S1. So that would be the abbreviated configuration for sodium. The next line that you have says that you are to write the number of valence electrons. Okay, so your valence electrons are your outer shell electrons. Your valence electrons are your outer shell electrons. Okay, so as far as our outer shell is level 3. So how many electrons are on a level 3 right now for sodium? How many electrons do you see in level 3? Since level 3 is our outer level. How many electrons do you see? Okay, so the superscript up here would be your electrons. We don't have any other level 3 orbitals. We don't have any 3p's or 3d's. So the only 3 that we have is 1 electron on the s orbital. All right. So the number of valence electrons would be 1. Now what I want you to do is when you're going through this, something that we're going to be adding is we're going to look at the group number. But I want you to look at, on the periodic table, you have 2 group numbers. You have the one that is numbered 1 through 18. Let me get my periodic table out. Okay, so you see the numbers 1 through 18, 1, 2, 3, all the way through the noble gases, which is group 18. But you also have these numbers that have the letters behind them. The groups that we are going to be focusing on are the ones that are the A groups. So 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. Okay, is one way that you can look at it. So we're going to be focusing on those groups. All right. So the group number, give me the number that is in front of the A. So as far as your sodium, what group is it in? I want the number that is in front of the A. What group is it in? Sodium is here. Okay, good. It is in group 1A, so you're just going to write 1. Okay, or if you want to write 1A, that's fine. Okay, but this is the number is what I'm interested in. All right? All right, let's go ahead and take a look at the next one. We're going to be looking for any types of patterns that we may see. So you have sodium. The next one on the list is magnesium, and I'm just going to write the symbol, magnesium. Okay, so find magnesium on your periodic table. What is its atomic number?
Up there on the right-hand corner, does that say group 1 or something?
That says group number.
Group
So
number.
sorry, that
Okay.
should be there. So it's just group number.
Yeah, it's kind of hard to see.
All right, so magnesium, what atomic number? Did anyone write it down yet? Good, atomic number 12. So again, we need to write the electron configuration, but you're going to write the abbreviated form. So what noble gas do we start with? Good. Okay, I have like the same 3 or 4 people that are answering questions. I need to see more of your names popping up. Thank you. Okay, so we have neon. Which is here. And we are writing, so this is again, you don't have to write the electron configuration through neon. Brings us to the next line, which means we're starting with our 3. And magnesium ends on what? Magnesium ends on what? So it's going to be a 3 what?
2?
3s2, good. Okay, so 3s2. So your valence electrons are again your outer shell electrons. We only have level 3, that's our outer shell. How many electrons do you see? So how many valence electrons does magnesium have? It has 2. 2 in its s orbital. Okay, then go to the top of that group. What is the number in front of the A? So what's the group number? It's going to be 2A. All right, try the next one. Aluminum. So aluminum is atomic number 13. Good, it's atomic number 13. All right, go ahead and write the electron configuration for that. Your noble gas configuration for aluminum.
What?
So I want the same type of configuration that you did here. I want you to write for the aluminum. So what do you start with? What is the noble gas that comes before aluminum?
Magnesium.
Where are the noble gases? This is aluminum. Where are the noble gases?
The right hand.
The right, okay, so the very far right group. These are your noble gases. Which one comes before aluminum?
Argon.
Okay, so this is number 13. This is number
Yeah.
18. Does 18 come before 13?
No, neon. Yeah, neon.
Neon. Okay, so it's going to be neon. And then what does aluminum end on? For your electron
3A.
configurations? That would be the group. Okay, so it is group
13.
3. But as far as your electron configurations, what would your aluminum end with? So go back to the shortcuts for the periodic table.
It'd be 3A.
You're still thinking group numbers. All right, so when we're talking electron configurations, that means you're going to have an S, a P, a D, an F. What does aluminum end on? Anybody put it in the, okay, good, so 3P1. These are your P's over here, P1, P2, P3, P4, P5, and P6. Aluminum's a P1. So you know it's going to end on a 3P1. You still need to write the things that came before it. So this was a 3S2 and then a 3P1. All right, so now how many valence electrons does aluminum have? Good, it has 3. 2 on the S orbital, 1 electron on the P orbital, 2 plus 1 is 3. And as was already stated, it's in group 3A. Is anyone noticing any kind of pattern here as far as the number of valence electrons and the group numbers? So if my question is, how is the group number related to the number of valence electrons? What would you put? You just write it in the chat. How does the group number compare to the number of valence electrons? They're in order. They're the same. If you're in group 1A, anything in group 1A is going to have 1 valence electron. Anything in group 2A is going to have 2 valence electrons. Anything that's in group 3A has 3 electrons. So we're going to do a couple more, and what's going to happen is you're going to see the same pattern. So that is your shortcut. You don't have to write out the electron configurations to figure out the number of valence electrons. All you need to do is look at the group number. Okay, and that will tell you the number of valence electrons. All right, so let's do the next one. Next one is silicon. Silicon is atomic number 14. Okay, so go ahead and write the electron configuration for that, the abbreviated electron configuration. What is the noble gas that I'll be writing down? Neon, thank you. And what does silicon end on as far as electron configuration? What will it end on? So this was on, they're on level 3. Aluminum was going to end with a 3P1 because these are P1s. Silicon ends with a, good, 3P2. So again, you still need to fill in everything else for that third level. We had neon. We had neon. Okay, then we go to the next line, which is your level 3. So you need to write everything through your silicon. So it's 3S2 and then 3P2. How many valence electrons? 4. 2 plus 2 is 4. And which group is it in? What's the group number? Okay, good, it's group 4A. So again, we see your group number tells you the number of valence electrons. Try not to pick these shortcuts because it'll speed up your ability to do the work much faster than having to write out the configurations. All right, last one we have for this is 1, 2, 3. Actually, we have 4 more. Phosphorus. So go ahead and start working through these. Get as far as you can. You got phosphorus, you got sulfur, chlorine, and argon. Phosphorus is atomic number 15, sulfur is 16, chlorine is 17, and argon is 18. All right, so go ahead and write the electron configuration. You're doing the abbreviated form for all of these. All right, I'm going to go ahead and start working through these. If you have any questions, please ask. All right, so atomic number 15, phosphorus. Phosphorus is still on, actually all of them are on your level 3, okay, period 3. So the noble gas that comes before all of them will be neon. Phosphorus ends on a 3p3, p1, p2, p3. So again, we need to write the S's that come before it. If you don't remember how to do this, 3s2, make sure 3s2, 3p3. Go back and look at the chart that we used, all right? The one we had for the orbital filling, the one with the arrows. All right, so pull that up so that you can use that. So this is going to be 3s2, 3p3. Phosphorus ends on a 3p3. So 2 plus 3 is going to give you 5 valence electrons. And the group number for phosphorus is 5a. All right, sulfur. Somebody put in the chat what the electron configuration is for sulfur. What is the electron configuration for sulfur? Put it in the chat. Okay, it has 16 protons, which means it has 16 electrons. Okay, so back to this one because there's a question on this one. Why do you have a 3s2? When it ends with a, it's on the p side, because you still have to write everything for that line. So what happens is when I have phosphorus is here, okay, we started out with neon. For our abbreviated form, we wrote neon, which means we don't have to write any of the configuration for anything leading up to neon. So this is all covered. But we have to write the configuration for everything that follows all the way through phosphorus. So when we get down to this next line, we still need to cover the sodium and the magnesium and all of these. All right, so yes, these are P's, but we can't skip the S's. Okay, so if you recall from your the electron configuration chart that you had, it had the 1s. I'm going to write it out real quick. 1s, 2s, 3s. Okay, I'm not going to write out the whole thing because we're just going to cover the part that we need. So you had the 1s, then we had 2p, and then your D started on level 3. Again, so I'm not going to fill in the rest of it. It goes, you can fill in all of this, but we don't need it. And then you had your arrows for the order of filling. so forth and so on. All right, now, what happens is when we write neon in brackets, that means we don't have to write the electron configuration for anything through neon. Neon ends on a 2p6. So that means this level is covered, okay? I don't need to write this. I don't need to write the 2s, and I don't need to write the 2p. You're filling in this order. So 1s2, 2s2, 2p6. That would be your neon, so I don't need to write any of that. We know that the phosphorus ends on a 3p3, so that means I need to write down to this level. But I can't skip the other stuff. So after 2p6, you still need to go to the 3s level. So I need to write the 3s before I can write the 3p. Okay? So you have to write the 3s and just fill it in. S's can only hold a maximum of 2 electrons. That puts you at magnesium. So that's why we write neon is this part right here. Neon is that part right there. Okay? And then we need to continue. So 3s2 and then 3p3 for the phosphorus. Okay? So you can't skip anything. All right, so going back to this. So we had sulfur 16. Did anyone write down the electron configuration in the chat? What is the electron configuration for sulfur? So if you notice, we're going in order. We did aluminum, silicon, phosphorus. We're now on sulfur. All right, so what would the electron configuration be? It's going to be the same as everything else, except what is it going to end on? It's going to be a 3p4. So since, again, these are all on level 3, everything that we're doing from sodium on, these are all on level 3. Okay? So your configuration should all start out the same, except for sulfur, it's the next one. It doesn't end on a 3p3, it ends on a 3p4. So we have 3s2, 3p4. How many valence electrons? How many valence electrons? 6. 2 plus 4 is 6. And then what group number is it in? What is the group number? 6A. Good. Okay, so keep comparing. Again, group number is equal to the number of valence electrons. All right, so as I said, these are going to end or begin all the same for your electron configurations because they're all on level 3. So what is the chlorine going to end on? It's not a P4, it's 1 over to the right, so it's going to end in a what? Sulfur ended in P4, good. Chlorine will end in a P5. Let's go ahead and do the next configuration. So argon, 1 more over. So we went from phosphorus to sulfur to chlorine, now to argon, going 1 over again. So what would that end with? 3p what?
6.
Good, 3p6. Okay, how many valence electrons for chlorine? How many valence electrons for chlorine? 7. How many valence electrons for argon? 8, good. All right, and then what is the group number for chlorine?
8.
For chlorine?
8.
For chlorine, what's the group number?
7A.
7A. And then what is the group number for argon?
8A.
8A, thank you. Good job, everyone. So once again, before we move on, in the chat, I want to see more than one person writing it down. What is the relationship between the group number and the number of valence electrons? What is the relationship between the group number and the number of electrons. Good, they're the same. So if you are asked, okay, so this is what I'm going to do. I'm just going to pick something on the periodic table, and I want you to tell me the number of valence electrons. Just put it in the chat. All right, so selenium, how many valence electrons? Just put it in the chat. How many valence electrons? Selenium. Good, 6, because it's in group 6A. Gallium, how many valence electrons? Good, it has 3. What about barium? Barium is right here. How many valence electrons? Go to the top. 2, be careful. Barium's right here. 2. All right, what about xenon? How many valence electrons? Good. Okay, now there was one exception to this rule. Everything here is going to have 8 valence electrons except for helium. Does anyone remember how many helium has? How many valence electrons does helium have? Good, that's the only one, all right, because remember that it only has 2 protons, so it has 2 electrons. That's maximum, all right? So it has the first outer shell filled with 2 electrons, and then it's done. All the rest of these can handle 6. Okay, so that would be it for this paper. Now I need you to go to the other note that looks like this. So open up the other one. So both of these notes will need to go into your notebook. Okay, so we've already done these. So it tells you group 1, group 2, group 13. They're actually using the numbers that are above this. So here's another way of looking at it. We looked at the numbers that are in front of the A. If you lose these large numbers, once you get into the double digits, 13, 14, 15, 16, 17, and 18, okay, the way you do this is take the last number. So ignore the one that is in front of it. 3A, 13, just look at the 3. So this has 3 valence electrons, 4 valence electrons, 5, 6. You're just ignoring the 1. If it's a double digit, ignore the 1. Just look at the last number. Okay? So, group 1, how many valence electrons? You're just going to go in and fill this in. So group 1, sodium, how many valence electrons?
1.
1. And yes, I will, after class, I'll update the table of contents so you can put everything in there. Next, magnesium. Let's go real quick, just type it in the chat. This is a shortcut, so group 2, how many valence electrons? Good, 2 valence electrons. Aluminum's in group 13. How many valence electrons? 3, good. Group 14. How many valence? Phosphorus is in group 15. 5, good. Sulfur is in group 16. Okay, what about chlorine? Good, y'all are quick. Last one has 8. Okay, group 18, looking at the last number, has 8 valence electrons. Okay, so the next part, we'll come back to the top here in a moment. All right, so the element dot notation, so you're going to have to do dots for your assignment 2. The dot notation is you have the symbol, the symbol for the element. So we're talking about sodium, symbol is Na, capital N, lowercase a. And you have dots on it to represent the number of valence electrons. So if it has 1 valence electron, it's going to have 1 dot. If it has 3 valence electrons, it's going to have 3 dots. If it has 5 valence electrons, it's going to have 5 dots. Now, listen carefully. Treat this as if there's a box around this. Okay? That means there are 4 sides to this atom. You have to have 1 dot on each side before you can start pairing them up. There has to be 1 dot on each side. So that means if you do something like phosphorus is 5, or let's say silicon has 4. If I did this, that would be wrong. You have to have 1 dot on each side first before you start pairing them up. Okay? All right, so I'm going to go ahead and put the symbols down so we can just add the dots in here. Okay, so next I'm going to add the dots. So sodium is going to have how many dots on it?
1.
1. So again, every valence electron it has, you're going to have that many dots. Magnesium has 2. I'm going to put my dots here. It does not matter what side you put your dots on, as long as you keep them separate until you have 1 dot on each side. So if you want to do something like, if you have your dots like this, that's fine. Okay? If you have your dots like this, that's fine. Later on when we're making bonds, you'll find it might be easier to put your dots on certain sides, just so it's not confusing. But as far as just doing your Lewis dot, it doesn't matter. It'll just make sure 1 dot on each side before you pair them up. All right, aluminum is going to have 3. Silicon, 4 valence electrons, is 4 dots. Phosphorus is going to have 5. Okay, so this one has 4 dots, and now I can pair it up. So does not matter what side you put it on. Sulfur has 6. Chlorine has 7. And argon is going to have 8. Okay, so I see that we only have 4 minutes left in class. So what we will do is I'm going to stop right there. This is going to take a few minutes to explain, so we will fill out the top part of the notes, and the bottom part we will finish up next time.
Hello. This is a continuation of the 7.1 notes. We had already done part 1, and we were going over this portion here. Right? So we had already discussed valence electrons and the different groups. So being able to identify the number of electrons, valence electrons in each of the groups using the group numbers, and then also writing the Lewis dot structures or element dot notations for each of them. All right, so the last part that we needed to talk about was dealing with the ions, all right, how they get their charges. So starting out with the top part, valence electron. A valence electron is an electron in the outer energy level. It is an electron available for bonding. An octet, so think numbers, octet, octa, like an octopus has how many legs? So an octet is a group of 8 valence electrons. The noble gas configuration, valence electrons equal that of a noble gas. For most for most elements, a noble gas configuration is an octet. Okay, so meaning your noble gases have, for most of them, okay, your noble gases have 8 valence electrons. Okay, so remember the exception to that rule would be helium. Helium only has 2 electrons, but that does fill up its outer shell. It only has 1 energy level, which can hold a maximum of 2 electrons, so it is completely full. Your other noble gases have an additional shell or more shells, and they have a total of 8, an octet, of valence electrons in their outer shell. So remember that this is the most stable configuration. They are stable, they do not react with anything else. Your noble gases do not react. For a few small elements like hydrogen, lithium, and beryllium, it is 2 electrons, the configuration of helium. So as far as the ability of your elements to react, what they are trying to do is to get the configuration, the electron configuration of a noble gas, to get that stability. But helium has only 2 electrons. So as far as the smaller elements, hydrogen has 1 electron. Lithium has a total of 3 electrons. Beryllium has a total of 2 electrons. Because they are very small, all right, what happens is rather than trying to get an octet of electrons, all right, for that stability, what they try to do is model helium, all right, so have the 1 energy level with 2 electrons. That would make them stable. Cation. This is a positively charged ion formed when a metal loses electrons, and we'll talk about why in a moment. All right, and then your anion is a negatively charged ion formed when a nonmetal gains electrons. Okay, so the way to remember these, your ion is charged. Okay, atom is neutral. Ions have a charge. Atoms are neutral because they have the same number of protons and electrons, same number of positive charges and negative charges that cancel each other out. Now with ions, what happens is you are either the particle has either gained electrons or it has lost electrons, so the number of protons and electrons is not the same. It is going to be charged and not neutral. So a cation, how to tell these two apart, all right? As far as your ions, they are charged. How do you know if it has a positive charge or a negative charge? So if you look at the word cation, look at the T as a positive. So this is saying that cations are positive ions. They have positive charges. Your anion has an N for negative. So anions are negative ions. They are negatively charged. So metals lose electrons. Forming cations. They lose electrons, which means they will have more protons, all right? And that will make them positively charged, so that is why they are cations. Your nonmetals, on the other hand, are going to gain electrons. They're going to pick up, bring in electrons, which is going to mean they will have more electrons than protons, more negatives than positives. So overall, they will have a negative charge. So they form anions. Let's go back and take a look at the electron configurations to see why it is that certain atoms will gain electrons while others will lose electrons. All right, so in the last video we had covered this. This is slightly different. I went through and redid them in the version that we did in class. We just went ahead and used the abbreviated version of the electron configuration or the noble gas configuration. In this one, what I have done is I've gone ahead and written out the entire configuration, the full configurations that you can see each one of those. All right, so what I have put a box around is the outer energy level, all right, and the orbitals that are occupied. So for sodium, sodium has one electron, one valence electron. Magnesium has two valence electrons, all right, in its outer shell. Aluminum has two in the s orbital and one in the p orbital, so 2 plus 1 is 3 valence electrons. Okay, and so forth and so on, all the way down to argon. Okay, so again, all I did was box the outer energy level, and then you add up your electrons to determine the number of valence electrons. Your Lewis dot structure, you have dots on your element symbol to represent the valence electrons. So if you have an atom that has 7 valence electrons, it will have 7 dots. If you have an atom that has 6 valence electrons, it will have 6 dots. The rule is you can have 2 dots on each side, all right, for a total of 8. But before you can start pairing them up, you have to have 1 dot on each side. So until you get to this point, like with silicon where you have 1 dot on each side, all right, the dots all need to be on different sides. You cannot start pairing them up until you have at least 1 dot on each side. So when we get down to 5 valence electrons, this is when we start pairing things up, okay? All right, so as I said, we're going to take a look at the electron configuration to figure out why some elements, your metals, are going to lose electrons while your non-metals are going to gain electrons. So the reason that you have these elements losing and gaining electrons is because they are trying to achieve the configuration, the electron configuration of a noble gas. Most noble gases have 8 valence electrons in their outer shell, except for helium. Helium is the one that has only 2, all right? So what we're going to actually look at is some of the larger ones. So what we have here, look at sodium. All right, sodium has 1 valence electron, 1 in its outer shell. Now, as I was saying, the noble gases, the majority of them, except with helium, have 8 valence electrons in their outer shell. So if sodium only has 1, that means it would have to gain 7 more electrons in order to have 8 valence electrons, all right, to achieve the electron configuration of a noble gas, because it only has 1. But there's another way of doing this. Rather than gaining 7 electrons, what it does is it loses that electron. So if it loses that, that means it no longer has a third energy level, and this will be its configuration. 1s2, 2s2, 2p6. So as far as its outer shell now, if you look at the configuration, it's 2s2, 2p6. That is now its outer level, all right? So now what happens is 2 plus 6, it now has its 8 valence electrons, all right? It is now stable like a noble gas. So that is why it is going to lose its electron, all right? As I was saying, it could either gain 7 electrons, which means it has to attract 7 electrons, or it can just give away, lose the 1. So when you're thinking about that, is it going to take in electrons or is it going to lose electrons? Think of it as the smallest number. Whatever the smallest number is, that's going to be easier to do. Is it easier to pick up, to attract 7 electrons? Is it easier to attract 7 electrons, or would it be easier to just get rid of 1? Getting rid of 1 electron is a lot easier than pulling in 7 more electrons, all right? So whatever, as far as number, whatever the lowest number is, that's what you're going to go with. So sodium is going to give away an electron. What that means, okay, so sodium is going to lose one electron. Okay, so what that means now is that if you look at sodium, sodium when it was neutral had 11 protons and it had 11 electrons. But now what happens is because it gave away, it lost an electron, that means it has 11 protons and only 10 electrons, 10 negatives. Well, as far as that, what would that be mathematically? What is 11 minus 10? 11 minus 10 is going to be a positive 1 plus 1. Doesn't matter which side you write the positive on, all right? So the ion formed, when you form ions, your symbol is going to have a charge on it. So this will be Na plus 1. Let's take a look at magnesium. So magnesium, this is the electron configuration of the neutral form. All right, magnesium has 12 total electrons. Atomic number of 12, that's 12 protons. It also has 12 electrons. So when you write out the electron configuration, you see that it has 2 valence electrons. So again, thinking about this, trying to get the stability, the electron configuration of a noble gas. Noble gas is having 8 valence electrons. It has 2. So it can either gain 6 more electrons, 2 plus 6 would be 8, so it needs to pull in 6 more electrons, or get rid of those 2. So that what happens is this becomes the new outer level, 2 plus 6, that's 8 valence electrons. So what would it be easier to do? Gain 6, add on 6, or lose 2? Remember, the smallest number is your answer. It's going to lose 2. So lose 2 electrons. So magnesium has now 12 protons. And I'll go ahead and put the symbols, positive, negative signs in the front. So it has 12 protons. It lost 2 electrons. Remember that initially you have the same number of electrons as protons, so 12 protons, and it had 12 electrons. But it just lost 2 electrons, gave away 2 electrons. So how many electrons does it have now? So 12 minus 2 would be 10. It has 10 electrons. All right, so again, math-wise, what's 12 minus 10? That would be 2, and it's a positive 2. So when you write your ion, it's the symbol with the charge up top, not on the bottom, okay? So it's superscript up top with the charge, plus or minus. So this is a plus 2. So noticing the pattern, if it loses electrons, it will have a positive charge, all right? If it loses electrons, it will end up with a positive charge. Let's take a look at aluminum. All right, so there's aluminum. Aluminum has a total of 3 valence electrons. So how many would it have to gain? How many electrons would it have to gain to make a total of 8? It's got 3. How many more would it need? It would need 5. So 5 valence electrons, or I'm sorry, 5 electrons it would have to take in, or get rid of 3. Add 5, or remove 3. So this is the new outer level. What would it do? It's going to lose 3. That's the smaller number. So aluminum as the neutral form had 13 protons, 13 positives, and 13 electrons, 13 negatives. Okay? It is losing 3 electrons. So how many electrons would it have left? Started out with 13, gets rid of 3. That means it has 10 electrons. 13 minus 10 is a positive 3. So that is the charge of the aluminum ion. Make sure it goes up top and to the right, on the right side, not the left side. Okay, silicon is a little bit different here. All right, so this is not one that actually gains or loses electron. It does what's called sharing. So that we will cover in chapter 8. So as far as silicon, it shares to form covalent bonds. All right, so as far as the ions, we're going to leave this blank. And we'll talk about this when we get to chapter 8. All right, so your next one, that brings us to phosphorus. Okay, so phosphorus has atomic number 15. That means it has 15 protons. In its electron configuration, you can see that it has 5 valence electrons. So the option is 5 valence electrons. It needs a total of what to be stable, to be like a noble gas? It needs 8. So the option here is, if it's got 5, how many does it need to gain? It needs to gain 3. 5 plus 3 is 8. Or it can get rid of the outer level so that this becomes the new outer level. 2s2, 2p6, and that would be 8 valence electrons. All right? So what should it do? What is the smallest number? Gain 3 electrons or lose 5? Gain 3 electrons or lose 5. What is the smallest number here? So in this case, what happens? Gain 3 or lose 5. The smallest number is 3. Gain 3. So gain 3 electrons. We're going to add 3 more to its outer shell. So it didn't lose electrons, it gained electrons. Initially, it had 15 protons and 15 electrons. 15 electrons plus 3 more gives me 18 electrons. So when I do this, 15 minus 8, negative 3 is what you have. Okay? 15 protons. The neutral atom had 15 electrons, but now we're picking up 3 more electrons. So 15 plus 8, or 15 plus 3 is 18 electrons. Subtract those, you're going to end up with a negative 3. So your phosphorus ion has a charge of negative 3. All right? So these right here, these are your charges. Again, make sure they are superscript. Top right of each of the symbols. Let's look at group 16, sulfur. Sulfur has, let me go ahead and put the symbol down. Oops. All right, so sulfur has an atomic number of 16. That's 16 protons, positive 6, and in the neutral state, it has 16 electrons. All right, but if you're looking at the electron configuration, it has 6 valence electrons. So either it needs to gain how many? It would have to gain 2 to make a total of 8, or get rid of that outer shell to make this level, the outer shell with the 8 electrons. So it either needs to pick up 2 electrons, 2 plus 4 is 6, so it needs 2 more to make 8. So gain 2 or lose all of these, which would be 6. Gain 2, lose 6. What is the smallest number? It's going to gain 2. So instead of 16 electrons, it will have a total of 16 plus 2, 18 electrons. Subtract that, 16 minus 18 gives you a negative 2. All right, so again, that is the charge of the ion, the sulfide ion. So yes, the name changes a little bit. We'll talk about that later. So instead of being called the sulfur ion, it's called the sulfide, ends with an IDE, sulfide ion. And this is the phosphide ion. Group 17, chlorine, has 7 valence electrons. How many would it have to gain? Gain 1 to make 8. 2 plus 5 is 7, so it needs 1 more. Gain 1 to make 8. Or lose all of these, which means it would have to lose how many? Lose 7. Gain 1 or lose 7. Which one is easier? Go with the smaller number. Gain 1. So chlorine has an atomic number of 7, that's 17 protons, which means it had 17 electrons, but it just picked up 1 more. So that means it has 18 electrons. 17 minus 18 is a negative 1. All right, so that is the charge of the chloride ion. Chloride ion is a negative 1. And then finally, we get to argon. Argon is the noble gas, and it has 8 valence electrons. So this is the stable form. Your noble gases will not gain and they will not lose. They don't gain, they don't lose, they don't share. They are stable all by themselves. All right? So as far as this, there will be no ion formed. Now, if you look at where these atoms are located on the periodic table, you'll find that these, group 1, group 2, group 13, these are all metals. They are to the left of the metalloid line. All right? These, on the other hand, are to the right of the metalloid line. These are all nonmetals. So general rule is, and since these are the groups that we'll be focusing on, okay, remember that everything that is within the same group will behave similarly, all right? So everything in group 1 has 1 valence electron. Everything in group 2 has 2 valence electrons. That means when they form ions, they will have the same charges. So sodium will have a positive 1 charge. Potassium, when it forms an ion, will also have a positive 1 charge, all right? Everything within the same group has the same number of valence electrons and will, and when they form ions, have the same charge. All right, so as I was saying, group 1, group 2, group 13, these are all metals. They are to left of the metalloid line. And these, group 15, 16, and 17, are to the right of the metalloid line. These are nonmetals. So the general rule is if it is a metal, it will lose electrons. This is what this says right here. Metals lose electrons, and they form cations. They end up with positive charges. Your nonmetals are going to gain electrons, these all gained, and they will form your anions, your negatively charged ions.